Okay, this is a short presentation just about working out chemical formula using the crossover method. You will need to learn all the basic ion formulas and complex ions formulas really before starting this, and the sooner you get to grips with these formulas, it'll be easier when you're doing balancing equations. Using formulae with simple ions in, for example, sodium oxide, it's going to have a sodium ion and an oxide ion. Remember, if you can find the element in the periodic table, you can work out its most common ion from the group that it's in. So sodium's in group 1 and it's a metal, so it's going to form a 1 plus ion. If it was in group 2, it'd form a 2 plus ion, group 3 a 3 plus ion, and then group 4 can usually form plus or minus ions, so we leave that one out. Then we do group 5 will be a 3 minus, then 6 a 2 minus, then 7 a 1 minus, and then the noble gases won't have a charge because they don't tend to form ions. So if I look at sodium oxide, sodium's in group 1, it'll form a positive ion, so it'll be Na+, and oxygen is in group 6, so that'll be an O2 minus ion. So we can write the two simple ions down first of all, so you write Na+ and O2 minus. Then if you swap over the number on the charge, obviously the charges would then cancel out, so you'd have Na2O1. We don't tend to write the 1, so that would be simplified to Na2O. Aluminium oxide, for example, then, aluminium is in group 3 of the periodic table, so that'll be a 3 plus ion, and again oxide will be O2 minus. We swap over the numbers only as the charge will balance out, we'll have Al2O3. If you happen to have ions that have equal but opposite charges, when you use the crossover method you can see you can simplify through. So for calcium 2 plus and oxide 2 minus, when you swap it over it'd be Ca2O2. You can then divide through by 2, which ends up with Ca1O1. We don't bother writing the 1, so that'll be CaO. So if the ions are equally but oppositely charged, then you just need one of each ion as the charges will cancel. So magnesium 2 plus and oxide 2 minus becomes MgO, and Na plus and Cl minus becomes NaCl. If you're going to use complex ions, the first thing I would suggest you do is you start placing a bracket round the complex ion so you can isolate the charge. We can always remove the bracket in the end if we don't need it. So we've got calcium nitrate here. Calcium is a simple ion, Ca2 plus, and nitrate is NO3 minus. So that we keep the actual charge away from the main part of the ions formula, the NO3, I put brackets around. So you'll see I've done brackets NO3 brackets minus 1 as the charge. Then if we use the swap over method, that would be Ca1 brackets NO3 brackets 2. You don't really need the 1, so we take the 1 out, so we can simplify it by removing the 1, so that'd be Ca open brackets NO3 close brackets 2. Sodium carbonate also contains a complex ion CO3 2 minus, so I started off by putting the brackets round. I put it with the sodium ion, used the crossover method, so we end up with Na2 brackets CO3 brackets 1. It becomes Na2CO3 as you can avoid using the 1, and therefore you can take out the brackets as well. Another example might be aluminium nitrate, so you can see the process again. So I have Al1 brackets NO3 brackets 3, so I have Al open brackets NO3 brackets 3. The reason we use the brackets is so that it wouldn't complex things. If I hadn't got the brackets in here, it would be Al NO O33, which quite clearly we do not mean 33 atoms of oxygen. So that's why we've got the brackets in there. You can carry on looking at these with two complex ions, so for example ammonium sulfate, where your ammonium complex ion is the positive ion and the sulfate ion is the negative ion. Again, write them in with the brackets to begin with, then cross over. You'll notice the sulfate afterwards has a 1, so we don't use the 1, so you can take the 1 out and you can take the brackets out. So it would be brackets NH4 brackets 2 SO4. Or an example might be ammonium hydroxide. So again, we've got one of each ion because they've got one opposite but equal charges. So in fact, we're just going to write one of each, but you can see the crossover method and removing the brackets as well. But as you get used to using them, you'll find you'll be much faster at putting together the formulae.